Let's start with the talk. A few, yeah, a few months ago, my girlfriend asked me, she's not very into technology, she's an optometrist, and she asked me, hey Uri, how does the internet work? And I was like, you get a web page, you download JavaScript and it runs. And she told me, no, I mean, when I go to some website, how does the information get from wherever in the world, all the way from Tel Aviv to my smartphone? So I told her, you know what, you nailed it. This is actually one of my favorite interview questions. What happens when you type www.google.com or you gotalafrontend.com in your browser? What really happens behind the scenes? Have anybody got asked this question in an interview? Okay, so it's not only my favorite question, apparently. And today we are going to answer this question. Speaking of internet, I also got Angular stickers, so catch me later if you want them. And to start with, a few words about myself. So I'm Uri, I do shoes. I really liked Diego's shoes. I don't know if you noticed them, but they are really awesome, those. Yeah. So I'm a Google developer expert, which means I go around the world, speak in conferences, get Swiss chocolate, spread Angular stickers, and I also blog a lot. You can find my blog here. I also love robotics, electronics, IoT. Usually I speak about IoT. This time it's just the internet without of things. And we are going to mention that a few minutes later, in a few minutes. I've also done salsa. Any salsa dancers in the audience? Oh yeah, you should tell that you met your wife dancing salsa. And I also played the Peruvian pan flute. I actually got it in Peru a few years ago when I visited. And here it is for you. I'm going to play for you a really short tune. Let's see if you recognize it. Yeah, thank you. That was the ringtone of Sergei's cell phone. And finally, last but not least, I work for BlackBerry. Yes, they still exist. So with that, let's start with F12. How many of you used the Chrome Developer Tools networking panel? Hit the Shift key. You can. Yeah, that's OK. All right, so I'm going to open a new tab and go to You Gotta Love Frontend, open the network tools. Yes, network tools. And it loads. I can see a bunch of pages requested, a bunch of resources requested from the server. So most of you are already familiar with this, and this is not what we are going to speak about, but I will start by showing you a nice trick. Apart from showing you this trick, I also want to really praise YGLF. Their website loads really quick. They have only, if I could only get this Zoom thing to work here, I know I can. Yes, I found it. Only 353 kilobytes transferred, so close to you, YGLF, for making this website load really, really quick. I don't know why it took 30 seconds, though. Maybe the Wi-Fi is not so great. Anyway, one nice feature that I found really useful in the DevTools is holding the Shift key. How many of you know what it does? OK, nobody, except for the one who met his life dancing salsa. So I'm going to hold the Shift key now, and OK, as you can see, my DevTools is dead. We are going to try that again. I call this luck-driven development. So let's open another window. And I found out that there is a trick that makes this work on my Chrome. I just refresh tons of times. And now I'm going to try this again. Hopefully this time it will work. No, DevTools stuck again. Last time, wish us luck with the luck-driven development. And the tab even doesn't want to die. Perfect. So many refresh, and then hit the Shift key. OK, I'll try that one more time. I know I can make it work. Pray to the gods of live demos. Okay. So, are you ready to see if it works? I think the Chrome browser is not ready. Okay, I'm going to try to time it accurately. Yeah, it worked. And now the DevTools are stuck again. Okay, one last time. I think I can do it. Chrome, please, bear with me. Just a short demo. Yeah, reload the browser, reinstall the operating system, format Sinecura time, yeah. Anyway, so I urge you to go home and try to see what the shift git does at F12. It basically tells you for each resource, for each URL in the list, what was the page or the JavaScript file that caused this URL to load. This is useful, but we are not going to spend any more time on the DevTools because they disappointed us. You see they are unusable. We are going to see some more cool stuff we can do in Chrome in order to understand what's going on in the networking when the DevTools don't work. And for that, I want to show you my favorite car sticker. It goes like this. Nachman Meumann. Do you know this one? Does anybody here have it on his car? Nobody, okay. So we are going to talk a little bit about networking and how does information get transferred from one place to another. Anybody in the audience familiar with TCP/IP? Road kernel drivers for networking? Okay. So basically, these are the 5 interesting parts that we have to take into account when talking about networking. The first one is HTTP, which is basically how browsers speak to web servers. And we are going to see that in a few minutes. On top, HTTP sits on top of SSL. That's the log sign that you see. And SSL gives us security. So HTTP is how browsers speak to web server, SSL adds security into the mix, and it's optional, but most of the new web APIs require SSL nowadays. Can you name a web API that doesn't work if you don't use SSL? That's correct. Everything doesn't work. So geolocation, WebRTC, microphone, Web Bluetooth, which I really love, they all don't work without SSL. You should use SSL and do it correctly. I just found out a few months ago that one of the Israeli banks, Bank Leumi, didn't use SSL correctly. And if you go to my blog, you can read what happens when you don't use SSL correctly. Spoiler, bad things, especially if you are a bank. So HTTP sits on top of SSL, use it, it gives us security. And then the interesting part begins, where my answer to how data gets from one point to another is, this is TCP/IP. We'll start with IP. So IP is basically some sort of delivery service. It has a computer, let's say your computer, and the web server, and it transmits data over the entire world from your computer to the web server and back. Now, IP has this concept of an IP address. Whoever got the IP address 127.0.0.1? Yes, that's localhost. And each computer has an IP address. And basically, IP knows how to deliver information from one IP address to another by going through many network devices, such as routers and switches. So it does a lot of magic in figuring out the best way, or sometimes the not-so-best way, to go from one point into another. We are going to see that in a few minutes. But IP doesn't do one thing. It does deliver information from your computer to the web server, but it doesn't deliver it to the right application. So it's like the post office man putting a box near the front of your building, but then we need somebody to take it to your specific apartment. And that's where TCP comes into play. So what TCP basically does, TCP takes those packets that come into your computer, and it sends them to the right application. So if you have Chrome and there is a packet that should go to Chrome, TCP takes care of that. And it uses a thing called the port number. So the port number is like the apartment number in your building. And for HTTP, we use port number 80. So basically, IP delivers the thing to the door of your building, and TCP takes it to the correct application, to the right apartment, and then SSL handles the security, and HTTP handles all the web stuff, like give me this file, here is the response, etc. TCP also does another thing, which is making sure the data gets reliably, because we all love the Israeli mail, and we know we all lose packages there. Same happens on the internet, and TCP makes sure that if some packet is lost, it will ask the other end to retransmit this packet, and those ensure that all the information goes from one way to another. So IP is like the Israeli post, and TCP is like the buyer refund mechanism on AliExpress that makes sure we get our data. And then there is Wi-Fi. We all love it and hate it, but we can't live without it. It's a fascinating topic, but we don't want to go here into how Wi-Fi works. If you got asked this in your interview question and you fail, do blame me. Apart from HTTP, SSL, and TCP, we also got another protocol that is very useful in the world of internet, and that is DNS, right? Does anybody know what DNS means? Domain name system, yeah, right. So all of you, you can get Angular stickers later, or you can try to play my pan flute. And DNS basically does this thing. I told you that IP assigns an address, numeric address, to each computer in the network. But when we go to YouGottaLove frontend, we type yougottalovefrontend.com, and we don't type an IP address. So this is where DNS comes into play. It translates the domain name that we type into an IP address. So it's basically Google Translate, but from domain names to IP addresses. And it works on another protocol that is parallel to TCP. It's called UDP. What does it mean? Yeah, user data, doesn't matter. It's actually unreliable something protocol, because unlike TCP, it does not ensure that the data actually gets to where it should be, but eventually it gets, and we don't really care about it. We just need to remember that we have DNS, and it doesn't work on top of TCP. So basically, whenever we open a web page, we first need to to send a DNS query to the DNS server, find the IP address for the domain we're looking for, and only then we can start opening a TCP connection, which is a process. I will show you that in a few minutes. And once we have the connection, we can start doing the SSL handshake, and only then we can start making the actual request. So there are a lot of steps we need to do before each request that we make from the browser. Now, it's the time to reveal some of the inner secrets of Google Chrome. Did you know about? Okay, so I'm going to change your life in a minute. Let's go back to Chrome. And this about is like the list of all the secret pages in your browser. It works on Chrome, it works on Firefox. It doesn't work on Internet Explorer, surprisingly. And we have a lot of URLs. If you are brave, you can try those ones at home, like induce browser crash for reals. Do try it at home, it's fun. But my favorite one, which I actually discovered while doing this talk, is Chrome Dino. Can you guess what it does? Yeah, the lovely dinosaur game that we all love to play when there is no internet. A nice anecdote. I told you that I do a lot of Internet of Things stuff. I created a version of this game where you control it by putting an EEG headset that can read your brain waves, and whenever you blink, it jumps. And thanks to Sarah Dresner, who asked me to bring it, I have it here, and you can catch me later in the lunch break and try it yourself. Break the high score. So thank you, Sarah. And back to the about. There are a lot of cool things for you to explore here. You can spend the entire weekend just wandering through this list, crashing your browser in different ways, and learning about the internals. But today we are going to look into the net internals. And the net internals is actually the parallel of the network tab in the developer tools, which, as we have seen, does not work so great. And basically what it does, it records every single thing that happens in the Chrome network stack. And we are going to see what happens now when I type yougotalofrontend.com and go into the website. Before we do that, let me just use the DNS tab to clear the DNS cache and also go to sockets and close all the active TCP connections so we get sort of fresh start. And let's also reset the capture. And now I'm opening a new tab and typing, let's open the developer tools because we love them. www.yougotalovefrontend.com. And notice that I typed it letter by letter. It will be useful very soon. And I open the website. We can see all the activity here. It actually starts with www.yougotalovefrontend.com from this cache. And we are going to stop the recording and see what things looks like from the internals from the guts of the Chrome networking stack. So I'm going to stop the capture. And you can see a lot of events there. Each line here is one component of the Chrome networking stack making some kind of request or informing us about something that happened. And I'm going to go a little bit down the list. So you can see here there are a lot of URLs that start with Chrome DevTools. If you remember, I opened the Chrome DevTools just after I started the window. So that actually also goes through the network layer. Even though the files are internal to Chrome, it's also being fetched to the render process of the browser through the network layer. And if you have been to Yoav's talk yesterday, it gave a really nice overview of all the caches in the browsers and all the things that go between the network and the server. So I'm not going to repeat that, but I'm going to show you something that you didn't know about your Chrome. Neither did I before I opened the net internals. So we have all those dev tools, but if we go down a little, we can see there are, let me close this small window, we can see there are a lot of entries that start with Google COEL/complete/search. And there are a bunch of them. Can any of you guess what these might be? Autocomplete, right. And if we expand this, we can actually see there is a field called Q, and it equals www, and then www, YouGotaLoveFrontend. So every single letter that I typed actually created a request that went into Google servers for figuring out the autocomplete. And I think that's pretty, for me it was pretty shocking that whenever I type something, it goes directly into Google, even before I had a chance to think about it. And that's one thing. If we look at the network tab, we can't really see this. Like, it only starts the story from the moment we hit enter and we actually loaded yougotalovefrontend.com. But when we look into the net internals, we can see all those requests happening before we even started our journey to yougotalovefrontend.com. So whenever you ask what happens when you type yougotalovefrontend.com and enter, you now know that there is actually things happening before you even hit the enter. And as soon as we actually hit the enter, there were a few things that happened. If you remember the slide from before, we had HTTP, SSL, TCP, and then we also had DNS. So I'm going to show you how this is reflected in the net internals panel. And you can see here, I got this, where is it? HTTP stream job. Yeah, I know it's somewhere here. Yeah, you can see here I got this HTTP stream job that wanted to connect to yougotalovefrontend.com. And in order for that to happen, we had to open a UDP socket to resolve the host name. So what does yougotalovefrontend.com, what IP address does it point to? And then if we look a little bit below, there is a host resolver job, which is the DNS. So we got the HTTP, and then we got UDP and DNS. That's the DNS block. And if we actually look into this host resolver job, we can see that it started by asking for yougotalofrontend.com, and then 133 milliseconds later, we got the result, which is this IP address. So this is the IP address. So we can see from the network stack that we wasted about 100 milliseconds just for the DNS part before we even started the TCP connection. And as soon as we got the DNS result from the DNS server, we also had a, where is that? We had HTTP, we had a SSL. So HTTP created an SSL connect job because this is a secure site. So we had HTTP, now we have SSL. And SSL created the transport connect job, which is actually the thing that opens the TCP socket and goes TCP IP. And this is where the operating system comes into play. And we'll see that in a moment. So basically, this was a really brief tour of all the information that you can get from net internals. And you often get asked, what is it useful for? Like, except from time where the network tab gets stuck. So here are a few things you can do with net internals. Whenever you have a new link that opens in a new tab, it's really hard to get the developer tools show before the page loads. And you can use the net internals tab to see all the network activity that happens when you open something in a new tab. Or if you send an analytics request when this page, when the link is clicked, you can also see that in the net internals. You can also remove things from, see what's in the DNS cache and remove things from the cache, like we did at the beginning of the talk, so in the beginning of the demo. So the DNS resolution will happen again, and you will get the real timing of how much time it takes for the page to load when you have no cache. And you can understand what happens in multiple tabs. This is one central place where you can see all the activity from all the tabs in your browser. So if you have a few tabs performing requests at the same time that may affect each other, you can see it all in the net internals tab. And finally, I think you have also mentioned service workers, and we don't get into them here, but they are cool technology. You can actually see what service workers are doing behind the scenes. So that's it for net internals, and let's discover a little bit more of TCP IP, like the lower level of the protocol. Before we do that, let me actually real quick tweet the slides so you can all have them on if you check out my Twitter. Don't go into Madlena's page. Check. And the next thing we're going to do is just introduce you a few command line tools. So one of them is called NSLookup, and it's a nice way to experiment with DNS. So if I want to know what yougotalabfrontend.com resolves to, I can just type NSLookup, the address, and I get the result. That's the IP address of yougotalabfrontend.com. And then another nice tool, let's say I wanted to know, to answer my girlfriend's question, where does the data go to in the world between my location and that server? So there is another cool tool called traceroute, or traceRT on Windows, which lets us see all the paths this information, these IP packets travel through. So we are going to use it with the IP address that we just found to see how far away, how many routers there are between us and yougotalabfrontend.com. Let's hope the Wi-Fi is fast here. And as this list will fill, you will actually see a list of all the hops of the points that each packet is going to on its way to yougotalabfrontend. So right now, it's still in the local network. And this traceroute tool is available on Windows, Linux, Mac, Android. There are also graphical versions, online versions that can show you points in the map of where the packets are going to. And this is being a little bit slow, but we can already see that there is some router in the way that does not answer the requests. So you can type any IP address that you like, and you will see all, or probably most of the hops in the way to the destination. We'll leave this running, and move on to a more interesting tool called Wireshark. Have anybody used Wireshark before? So most of you are familiar with it. Let's go with a nice demo. There is a website I like. OK, traceroute is getting a little bit faster, but let's leave it alone. You can try it at home if you want. Let's go to one of my favorite websites. It's purple.com. Do you know it? It's all purple. And I'm going to open Wireshark and ask it to capture packets on my network. And I'm going to refresh this page, so it will reload. And the reason I chose purple is that it uses HTTP. It doesn't use HTTPS, so we are going to be able to sniff all the packets. And it's also a very simple website. I'm going to ask Wireshark to filter only thing that happens on port 80, which is the HTTP, the port that HTTP uses. And I can see here a pretty long list of packets that happened from the moment I started the connection. I can see here a packet that has this SYN modifier next to it. You will be able to see it in a moment. So I have this SYN. SYN basically means, hey, I want to talk with you. And then so I send that SYN to the remote server. And then the remote server tells me, OK, I agree to talk with you. So all of this exchange is part of the TCP protocol, and it happens even before our request is sent down to the server. And we can actually see that the next packet is an HTTP packet over the same connection where I ask for purple.html, the main page of this website. And then we can see there is like another ACK packet. It opens another connection for some unknown reason, and then it also sends me the response with HTTP OK. And as you can see, there is a lot of chatter going on the TCP level, even before we get to HTTP. One thing that Wireshark does to make it easier for us, we can right-click and follow TCP stream, and then we get only the data that was transferred over that stream. So we can see there was one request to purple.html, and then we had the server response, HTTP 200, OK, you got it, and the HTML code. And then using the same connection, the browser sent a request for index.css, and then we can see the server response as well, and we can go on and on. But it would be more fun if we actually talk to our servers ourselves without a web browser. So that's what we are going to do next. And again, you can download Wireshark, do this recording at home, and look into all those interesting chatter that goes into TCP, all those SYN, ACKs, and so on, and all of those black packets that are probably retransmissions because the Wi-Fi is not so good. So the final thing we are going to do, we are going to try it ourselves with performing an HTTP request to purple.com. I'm going to open a tool called PuTTY. You can also use Netcat or Telnet on Linux or Windows. And this tool basically allows me to open a TCP connection to a remote server. In this case, I'm going to connect to purple.com, and I'm going to make the HTTP request myself. So I'm going to be the web browser for this demo. So I'm connected to purple.com, and I say, hey, give me purple.html using the HTTP protocol, and I'm looking for the web page at purple.com. The reason I have to say it is because sometimes a single web server hosts many websites, so this is how I let the web server know which website I'm looking for. And you can see here, I got a response from the server. So this is also a thing I encourage you all to try at home. Just imitate a web browser. And as you can see, in 30 seconds, I got a web browser working. Now I just need a rendering engine, a JavaScript engine, and I'm ready to go, my personal web browser. And to sum up, what I want you to take away from here. First of all, we all do minifying, Balden rollup, Webpack, etc. And sometimes you wonder, why do we work so hard? So the reason is, network is complex. there is a lot of chatter going in TCP, in SSL, and unless we understand that, it's really hard to build high-performance websites. If we have a lot of host names that we refer to, there will be a lot of DNS lookups, and that takes time, as you have seen before. And the second thing, use browser tools to even better understand networking. Do to about, play the Dino game, and then play with net internals. I put a lot of resources that you can use. I'm also broadcasting the link to the slides using the physical web, so if you have Android phone with Bluetooth open or iOS with Chrome, you can probably get it. If not, catch me later. And I also put a link on Twitter. What happens when is basically a good answer to the interview question I told you about, so do check it out. And then there is a bunch of things about networking, how it works in Chrome, net internals, and etc. So, thank you. That was it. I hope you learned something new.